1, our radius is 1, so that's why that point right there is 1, 0. We also then therefore know that this point up here is 0, negative 1. Okay, oh, that is, I don't know why. Obviously. Negative 1, 0. 0, negative 1, correct?
Correct.
Anybody have a misunderstanding or not knowing why I did that? Okay, okay. So now, is that gross? Why? It's hair. Nobody can eat your hair. No, never. Onward. So this right here is 0 degrees. We all know that, right? This is also the same thing as 360 degrees, correct? Okay. They mean the same. Well, they're not the same thing. They are coterminal, correct? Okay, this guy right here is 180 degrees. And once again, we know that because we know a whole circle is 360. I cut him in half is 180. Okay, this is coming in, and if we cut that, see, that's why, look. And then we go from there to cut that guy in half, so what do we get? 90. And the reason why I used to have you guys actually draw your unit circle on a plate back in the day. So then you get the fourth quadrant. Right? But you know why we increased by 90 degrees. So this is 0, 90, 180, 270. And then back to 360, correct? Well, once again, we also know this is 2 pi. If we cut that in half, this is, so we have 0 and 2 pi. This guy right here is pi. We cut pi in half. Pi half. Right? And so therefore 90 degrees is pi half. 0 plus pi half is pi half. Pi half plus pi half is 2 pi half, which is pi, right? 2 pi half plus pi half is 3 pi half. I've been told that some other teachers may have not explained the unit circle. They just told you to memorize the unit circle. I am going to show you where the unit circle came from. Okay? I think it helps you understand it a little bit better. Okay, anyway, 3 pi half plus pi half is 4 pi half, which is 2 pi. Question. Okay, the next thing that we're going to do is I cut this guy in half. So if you have pi halves, you cut in half. What do you have? Pi fourths. That's this guy right here. Where he is also 45 degrees. Right? Last time we were in class, we talked about reference angles. Notice this is 45 degrees from here to here, correct? This is also 45 degrees. So if I go 180, cut back 45, this would be 135. Or this is 4 pi fourths, correct? Pi is 4 pi fourths. Cut back pi fourths. This guy is 3 pi fourths. With me? Who's your teacher at? Merch. Red Spangy Spank. Who's that? Mitzi Mitch?
That's what we should say.
What? I just like to call her the Merch. Not Merch, the Merch. Okay, so this is also 45 degrees, right? But 180 plus, forced around, and that would just keep adding, because 45 plus 45 is 90, 90 plus 25 is 135, 135 is 25. 180, 180 plus 45 is 245, 225 plus 25 is 270, 270 plus 45 is 315, huh? And then 315 plus 45 is 350. Then you can just keep adding pi parts all the way around, and then you can get pi. That would be 75. Okay. Well, ladies and gentlemen, in geometry and in algebra 2, we learned our special triangle. Correct? This guy being 45, this guy being 45, and this guy being 90. Okay, isn't that basically what it looks like on our triangle as well? If I briefly bring him down, 45, 45, 90 triangle, correct? You guys see that? Maybe that makes some sense. Okay. So, we have our 45, 45, 90. Now, this is what this comes. This is called an isosceles triangle, correct? This guy's x, what's this guy's x? Still x, because on isosceles triangles, they're both the same, right? Everybody there with me? You okay? Okay, I'm going to find the hypotenuse by doing good old Pythagoras. X squared plus x squared equals our c squared. How many x squareds do we have? 2 of those. And now what? X root 2 would be what that is. Correct? Everybody see where that came from? Okay, that is our special triangle, and it always have that ratio, no matter what. Right? Okay, so well, with that, here is our triangle on the unit circle. What's this distance right here? Remember what this was going on the circle. This one right here is here, that's 0, 0. This is 1, because our radius is 1, right? Radius from here to here is 1, because that's a radius. Right? Everybody there with me? And you circle with me, right? Okay, with that being 1, therefore I know this 1 has to correlate with this x root 2, doesn't it? If I solve for the x, therefore I will know what the other sides are going to be, right? Okay, so x root 2 equals 1. How do we solve for x? Very simple. X is 1 over root 2. Okay, why is that bad in mathematics? Does anybody remember, recall? We can't have yeah, all that stuff. We can't have a radical in our denominator. Anybody know why? It's irrational. That is part of the reasoning. Okay. Back when my dad's day, not my day we had calculators. I had that lovely calculator right there. That might have even been the one I used in high school. Okay. That lovely calculator is what I had. So we had it. But back in my papa's day, which he's like 62, I don't know about some of your parents, I don't know how old they are, but sooner or later, at one point, they didn't have calculators to be used. Their calculators, a computer filled the whole damn room, right? That's how what computers work. So, an irrational number, that's exactly what you said. What is an irrational number? It's a number that goes on forever, right? How do I divide a number by a number that goes on forever? They couldn't. They didn't know how to. Well, we got smart and we did an algorithm that plugs it into our calculator. That's how we're able to do it now. To be honest, nowadays this should be an acceptable answer because we are able to do it using our machine, correct? They had slide rules. They weren't able to do so. What they had is a bunch of charts. Okay, so like in the back of your math book, they have a bunch of charts that say, oh, square root of 1 is 1, square root of 2 is this, and so forth. So you just have to look back at the chart to see what it equals. Does that make sense what I'm saying? Well, if you rationalize the denominator, I have root 2 over 2. Can I divide a number that goes on forever by 2? Sure. Just sooner or later, I just have to say to myself, I'm going to stop somewhere, right? That's basically it. That's where they got the estimate from. Does that make sense what I'm saying? So that's why it's at root 2 over 2. Because when it's he's 1, this guy's root 2 over 2, because this is root 2 over 2 as well. Does everybody understand that? Well, notice this is 0, 0. What's this point? Well, I'm over root 2 over 2, and then I'm up root 2 over 2. Correct? So therefore, this point right here, root 2 over 2 is root 2 over 2.
Well, what?
Okay, so get back over there. Okay, so once again, understanding this radius is 1, right? Because this is 1, it has to follow still this ratio. No matter what number you have for your radius or your hypotenuse or your side, it's always going to have that ratio. Okay, that's why it's a special sign. Okay, with that being said, I went ahead and set 1 equal to the x root 2. I divided it, so I have 1 over root 2, and then I rationalized it. Does that make sense to you? Like times by root 2 to top of 1 times root 2 is root 2. Root 2 times root 2 is root 4, which is 2. Are you okay with me now, Paul? And that was the x value. Notice the x values are on the side like this. Are you okay with that? Everybody okay with understanding where I got those values from? Some of you guys are like, I don't see what the unit circle is. Well, I'm trying. Okay? And as we go through the unit circle, that's where yesterday's reference angles come into play. Okay? Yesterday's reference angles come into play because, notice I have the same triangle 4 times up there, don't I? Okay? Because they're all 45 degrees away right here. So basically I can make this triangle, which is 45, that's a 45 degree. Well, excuse me. With a radius of 1 still, right? So with that being said, isn't that going to be the same coordinate? Where the hell did I lose my paper plate again? Okay. Alright, so we also know that our circle is symmetrical. See, here's 45 degrees right there. I know you might not see the indentation, but there's that, there's the 45 degree angle. Okay? Notice this coordinate and this coordinate are symmetrical, meaning they're at the same spot, right?
Right.
So they're the same coordinate.
Right.
Okay? That's why I like to use it visually. And then with that, okay, only thing that we need to know is, well, he's root 2 over 2, therefore he's root 2 over 2, root 2 over 2, but this guy's negative. Why? Somebody tell me why he's negative? Go ahead, Lindsay. If this is xy axis, this is 0, 0. We went left, so therefore our x value is negative and our y value is
See,
positive.
that one helped me so much, like, when we quiz last week. Cause, like, I just tried to memorize it, and I was, like, trying to, like, compare, like, across corners, but I thought I was seeing it as, like, a graph.
That's what I came for. Well, thank you. I know I'm good at this. Maybe right, maybe not. But. So notice, and then once again, this is where root 135 is. If I flip it down, right, this coordinate and this coordinate are the same, correct? Okay, so hence why this guy down here is root 2 over 2, root 2 over 2. So they're both negative. Because notice, they're both to the left and then down for our y-axis, correct? Okay. Notice you could also say 2 options. I have this angle and I have this angle. Either I can flip him down to here or I can flip him over to here. They're the same coordinate as well. Okay? So this guy's at root 2 over 2, negative root 2 over 2 because he's positive x but a negative y. Ladies and gentlemen, that's your 45 degrees. Everything that correlates with 45. Now once again, if you just memorize this quadrant and understand the reflexive properties of our circle, it's the same thing over and over and over again. You just have to understand is it negative or is it positive because of where the x and the y are, correct? Everybody okay? Okay. Well, I am now going to go on to 30 degrees. This guy right here. So once again, going back to my circle, we're at 90, right? Yes, sorry, Nikki. Okay. Do you understand where the root 2 over 2 came from? The coordinate way and over on a positive angle. You okay with me? Is everybody good? Okay. Well, once again, this guy right here is what? 90, and we're going to cut him instead of half, we're going to cut him into thirds. But anyway, this is just where the lines came in. That's what I was trying to show my kids when I used to do this, but then it got so nasty and ugly that I decided to stop and just give you basically that picture later. Okay. But anyway, I think this helps understand where your symmetry is coming in and why they're there. Okay. So notice if I cut 90 in thirds, what is this angle now? 30. That's how I got my 30 degrees. Well, if I cut pi halves in a third, what is that angle? Pi sixths. Okay. Everybody there? So, once again, this is a reference angle of 30 degrees. This is a reference angle of 30, 30, and 30. Huh?
Why do you pi six?
Pi 6, because if I cut pi halves by a third, because didn't I take a third of 90? And that's how we got 30, right? So a third of pi halves is a pi 6. Right? If you're taking a third of pi 6, you just want to shoot across. Okay? So this is 30, this is pi 6. If I'm cutting back 30 from 180, this guy's 150, right? This guy's 6 pi 6, but I'm cutting back pi 6. What would he be? 5 pi 6, right? PK, do you work tonight? You don't work a Friday? How about Saturday? You work tomorrow. It's a busy day. Scallywags. I used to work 24 hours a week. That was my workload when I was well, excuse me, 20 hours a week. We work 2 days of the week, 6 hours, and on Saturday. Well, this guy is once again 30, so we got 180 plus 30 more is 210. Everybody understand why the 210 there? 180 plus 30 more, right? Well, this is 6 pi 6 plus 30 degrees, which is pi 6, so this guy is 7 pi 6. So maybe that helps you then memorize where the things are just by understanding you're just adding 30 in the reference angles, right? This guy is 360. We cut back 30, so therefore this is 330. But this is 12 pi 6. We cut back pi 6, therefore this is 11 pi 6. Because you know there's 2 pi is 12 pi 6, right? Makes more sense? It almost takes me a whole class period to do this, but we're going to see. Okay, is everybody good there? Well, notice when you saw this, if you had your own plate, you cut it into thirds, you notice there's 2 marks there, right? Because you have your 30 plus another 30, so therefore 30 plus 30 is what? Our lovely 60, and that's why this guy comes in. I'm waiting for the coordinates just for a second because they come off the same triangle, to be honest. But the 30, 60, 90 triangle and a 60, 30 triangle are the same thing, right? You know what I'm saying by that? So I'm just going to wait for those just for 1 minute and I'll do that there. Well, notice isn't that 30 plus 30 gets me to 60? So the pi 6 plus pi 6 gets me to 60. So what's that? That's 2 pi 6, which is pi thirds. Everybody understand where I got pi thirds? Okay. Well, once again, that's a reference angle, correct? 60 degrees. That's what it said. So 180 cut back 60 is what? 120. Well, isn't 120 just double of 60? So therefore this is 2 pi thirds. Right? We're there.
Is that some
hopefully now you can see where the radians and the degrees come from, and you don't have to just go ahead and memorize the degrees. Like last year, some of my kids just memorized degrees, and they converted, and it took them forever, right? It's just a counting process. You're just continually adding and adding and adding, but then you just simplify the fraction. I'm going to show you really quick. Okay? Alright, so now I'm going to show you the math behind it. Okay, where does the coordinates come from? Well, once again, this is what it looked like if we had that 30 degrees down here, correct? Okay, this would be 60, this is 90. Once again, this is, we know this is 1, don't we? Okay, how many of you guys know the special triangle for 30, 60, 90? Well, if you don't, let me prove it to you. This is 60, 60, and 60. What do we call that guy? Equilateral. I'm just going to pretend here that this guy's going to be 2x. This guy's 2x and a half. I'm going to use it here just a second. Okay, that means all the sides would be the same, wouldn't it? Okay, so what they did is they cut this guy by an angle bisector and pulled him down, and that made it an angle bisector and a perpendicular bisector at the same time. Okay, which cuts him in half, so therefore then you're 30. So therefore this also is a perpendicular bisector that cut him in half, so what's this length right there? X. So if I looked over here, the side opposite is 2x. The side opposite of 30 is x, and then if we do the Pythagorean theorem, we'll call him b for right now. X squared plus b squared equals 4x squared by doing the Pythagorean theorem. Subtract over, and then take the square root. That would be where x root 3 came in. So that's where this ratio comes in. So notice, ladies and gentlemen, what is my 2x value equal to in this ratio? Well, 1. So what's my x value? 1 half. That's my x. Multiply by my x, and on this side, it's 1 half times root 3, which is root 3 over 2. So therefore, what's my coordinate when I have my unit circle? Well, once again, this is 0, 0, right? So I'm over root 3 over 2 out the half. Okay? So this coordinate would be over root 3 over 2 comma half. And that makes sense because doesn't that look like halfway about up that axis? Right? And once again, now we just use symmetry. Right? Where this point and this point line up and match. And we can flip them down as well, right? Everybody understand? Hopefully the plate's giving you a visual of what's going on. Okay? So therefore this point down here is root 3 over 2 comma negative a half, because once again, over x down y. Right? This guy is root 3 over 2 comma half, but this guy's a negative, so it's left and then up. Correct? And then this guy is negative root 3 over 2 comma negative a half. Now I understand my unit circle kind of is ugly right now, but basically I'm just trying to show you where it comes about. I really do suggest you print one off and have it with you. Now I do suggest you memorize it. The whole goal of this is, like, for example, if I say what is the cosine of pi 6? You go over there to, you should think, all right, pi 6, that's root 3 over 2 comma half. That's what I expect you to do. And then you're like, oh, cosine is the x value, so it's root 3 over 2. That's basically what my goal is for you guys to do this. Okay? Alright, now we got this guy. Well, isn't he just basically this triangle right here, but just flipped? Instead of this being 60, this guy's down here. Right? So it looks like this more. So notice this is still 1, so the side opposite and is still a half, and the opposite of this would be root 3 over 2. It's the same triangle, isn't it? We've already proven it, so now we're going to go over a half, up root 3 over 2. I'm seeing light bulbs, and I like that. Okay? Now here's something that's going to trick you just a second. You're going to say, really? Because why? It's reflective over and over and over again, right? That's all it is. Now, maybe you struggle. Let me teach you something here. Okay, watch this lovely little pattern. Maybe I know Miss Spangler shows this. 1 is the same thing as square root of 4 over 2. Because what is the square root of 4? 2. And what's 2 over 2? 1. So what is the square root of 4? Square root of 3, square root of 2, square root of 1, square root of 2. Square root of 0, square root of 1, square root of 2, square root of 3, square root of 2. Pattern. See it? 1 is square root of 4 over 2. Right? And what's square root of 4? 2. 2 divided by 2 is 1. So if I wrote it square root of 4 over 2, that is 1. Right? Square root of 4, square root of 2, square root of 2, and square root of 1. Square root of 1, square root of 0, 0, 0 divided by 2 is 0. Right? Square root of 0, square root of 1, square root of 2, square root of 3, square root of 1. And it's done. So it's not this massive thing, right? Every time I see you in circle, people are like, ah! Okay? And there it is. That's our unit circle. That's what I expect you to memorize. But really, it's not too shabby if you think about reflecting. If you think about that pattern I just showed you, right? It's not too bad of a thing to memorize. It's not going to take you a million hours to do so. Okay? Everybody there? Understand where I'm going at? Now, let me show you what I want you to use this. Alright, we're doing really good at it. Okay, now how do we use the unit circle? To be honest, 4-3, which we're going to learn on Wednesday, is using a lot of the unit circle. I personally think 4-3 is more unit circle-ish than today is, to be honest. Okay? Well, we have the 6 trig functions, don't we? You guys know the 6 trig functions. What are they? Sine, right? Cosine, and please don't call them sin and cos. Okay, they're sine and cosine. It's just an abbreviation, so that's what they are. If I hear somebody say tan, I'm going to whoop up. Okay? Not a big fan of that. Use their proper terminology. Sine, cosine, and tangent. Okay? Now, some of your teachers might only taught you those 3 last year. They're supposed to teach you the 6. Who corresponds with sine? Does anybody remember? Cosecant. Arcsine helps us find an angle. Cosecant is another trig function. It's just a multiplicative reciprocal of sine. Cosecant is the exact same thing as 1 over sine. So notice if I times sine by cosecant, what do I get? I would get 1. That makes sense? Just like 1/3 and 3, if I multiplied them together, I would get 1. They're multiplicative reciprocal. So is cosecant and sine. They're multiplicative reciprocal. Yes, ma'am? CSC. CSC. Sorry about that. Cosecant. Okay. Who goes with cosine? Secant. Secant is 1 over cosine. Okay? And who goes with tangent? How many of you guys had your teacher teach you this last year? Thank you. Thank you. Where else do I have that notation to me is arc sine. They might have called it arc sine, but they used that notation. Why don't I like that notation? Because let me ask you guys this. What does this mean? X to the negative 1. That means 1 over x, doesn't it? It also means inverse. That's why I think it's kind of weird that they do that, to be honest. Because this is not 1 over sine, which is cosecant, which a lot of people think it is. It's not. That's why I don't like that notation, nor will I ever use that notation. Because when I want to see sine to the negative 1, I'm expecting you to know that's cosecant and not arc sine. Does that make sense what I'm saying? Bad notation. I'm telling you right out. Okay? That's why I will never use this. I will always write the word arc sine. Okay? Just beware. Okay? Anyway. So, how many of you guys remember what sine represents? Maybe I'll give you a little analogy. Some old hippie caught a hippie tripping on what? I like apple personally, but those hippies, they used to trip on acid, but nowadays we just do apple. They fall all over. Man, it sounds more appropriate for school. Some old hippie caught a hippie tripping on apples. And SOHCAHTOA, right? You guys all know that one. So, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. You don't understand? Some old hippie caught a hippie tripping on apples. Or SOHCAHTOA, but I always like to throw the old hippies on there. You know, some of you guys' parents are old hippies, aren't they? Your parents were? Grandparents? How old are you guys? Well, I just found out yesterday I could see freaking some of you guys' dads.
Peace, love, dope.
She's right here.
She's like, peace, love, peace, dimension.
My dad used to beat up hippies. Yeah, no offense, but he's kind of a close-minded man. Still is.
She's like, we should all be burning leaves, making love, and smoking drugs.
Yeah. 16 years ago, I'd be 16 if I could have had 50. Now, would I want to?
You could be my father.
Okay? But I'd also like to show you is, notice here, because in our unit circle, what was always our radius? Always. 1. So if I stood here, opposite over the hypotenuse, you're always going to just be the opposite, aren't you? And notice, what does this dictate? Is this the x or the y? The y. So, notice, sine is your y value over technically your radius. But in our case, what is always our radius in the unit circle? 1, huh? And so notice it's just the y value there. Hence why I just said, if I asked you for the cosine of pi 6, okay, cosine, notice that sine is y. What is cosine? X over, speaking of y. So, me personally, if I said, what is the cosine of pi 6, you go to pi 6 in your head. It's root 3 over 2 comma half, right? But cosine is your x value, so it's root 3 over 2. That's what I'm looking for you to know. Okay? Does that make sense what I'm saying by that?
Yes.
Look at your unit circle for me, Nikki. You have it drawn somewhere? Okay, go to pi 6. Okay, what is the coordinate? Okay, it's root 3 over 2 comma half. Write that down. Root 3 over 2 comma 1 half. So, and notice cosine is the x value there, which is root 3 over 2. Does that make sense? Who'd you have, babe? Murky Murk, huh? Okay. And then notice, I don't know if you guys remember from last year, tangent was sine over cosine, right? You guys remember that?
Yes.
Tangent was sine over cosine. So notice what's our sine? It is y over x. So therefore, what's cosecant? reciprocal. Because remember they are reciprocal, right? Does that make sense to me? And then secant would be hypotenuse over adjacent or your radius over your x value. What would cotangent be? Adjacent over opposite or x over y. Okay? So, let's do a few problems really quick. No problem, I apologize. Sorry you're tired today. Sorry I'm not funky today. Sure you're jumping yet? Okay, sure, that's a horrible jumping jack. And my stuff just fell on it. When you get this thing going, it just doesn't stop. Radius. Because notice, on other circles, they're not always going to be a radius of what? 1. So that's why, in our case, on the unit circle, the y value over 1, what is the y value over 1? It's just y. E2 y over r, it happens for every circle instead of just the unit circle. Are we good here, Paul? Okay. So, I'm going to ask you guys to use your unit circle right now, but hopefully later on, once again, you're going to wean yourself off of it and just memorize it, right? That's the goal. So I'd like you to say, okay, what is the sine of, let's go, 5 pi thirds. Okay, I want the cosine of 3 pi fourths. And then the tangent of, let's go, 7 pi 6. And notice that usually they could be in degrees, but most of the time they're going to start to be in radians, okay? You make me laugh, Roman. Can you feel the pressure? No? Oh, yeah. What are you being sassy? Huh? 2 of them, not that way. That's why Robert's desk is broken. Can you feel the slant? Because I went like this. Hold on, let me take out my phone. So I'll be like, oh, so, but I did it with a whole row of kids to see if group number 7 in the back could feel it. So that's a lot of weight in there. And so one time I did that, and the pressure pushed back, and it went crouch. No, I'm good. I don't want to break any more. That's why I did it on that one. Yes, that one person's extra heavy. Way to go, Cody. It does. They get bruises. Anybody help me out with sine? 5 pi thirds. Anybody get it? Go to 5 pi thirds. Okay, we're looking at it. It is 1/2 common negative root 3 over 2, right? Sine is x or y? Y. So therefore it is negative root 3 over 2. One way to remember is alphabetically. Cosine x, sine y. Do you remember who goes with who? Am I off on the coordinate? 5 pi thirds? 5 pi thirds. That's down in the bottom quadrant, right? The same thing as 300. Am I correct? Okay. I was going to say, hopefully not. I'm not wrong. Okay. 3 pi fourths, that's 135 degrees. That's the coordinate negative root 2 over 2, comma root 2 over 2. Cosine is the x, so therefore it is. You see how I'm doing this? This is what I want. This is what I'm hoping for. You see how I'm just, boom, I know what quadrant it is, coordinate it is, and I'm just like, bam! Okay? All right. Now we go to 7 1 over root 3? No. Rationalize. That's root 3 over 3. Okay? That's what I'm looking for. How we doing? You okay, stuff? A lot of stuff? Okay. One more thing. So like for example, what if I gave you the coordinate negative 3, 4? Negative 3, 4 is up here, right? I want you to tell me all 6 trig functions knowing that point. What does that mean? Knowing all 6 trig functions knowing that point. Well, that's sine, cosine, tangent, cosecant, secant, cotangent. By the way, a lot of people think cosecant goes with who? Cosine. Why? Because of the cos, right? My little saying is the cos don't go. Do you remember that? The cos don't go. Okay? You don't? Well, because you slept a lot. So, the cos don't go. So cosecant goes with sine because notice the cos and a sine, right?
We should say it out loud all together.
The cos don't go. You gotta have a little accent. Nope, not like that.
Everybody together.
Ready? 1, 2, 3. The cos don't go. Pitiful. I heard nothing from here. Nothing. Anyway, so basically I can make a triangle out of that point, right?
Right.
Where this guy is negative 3y because we're over negative 3, we're up 4. Can anybody tell me what this side over here would be? 5 because of the 3, 4, 5 triangle, if I do Pythagorean theorem. I'm trying to do quicker, that's why I picked that one. Okay? So what's my radius here? 5, isn't it? So therefore, remember, cosine was x over our radius. So what would be the cosine of this angle? Negative 3/5.
Yeah.
What would be the sine of this? It'd be the y over the radius. What's our y value there? 4 over 5. Or you could just sit here and say, opposite over opposite. Opposite over adjacent. And you get the idea. Okay? Woo-hoo. One more theorem. This is a big section today. Shush. Sometimes I lie. Ask my wife. Honey, did I do the dishes? Sure. No, I like to do dishes. Out of any home chore, the dishes I will do. My least favorite is the bathroom. I kind of like the dishes because I can see them going away. You know what I mean? I can see the pile
You can see the
going
beginning
away.
and the end.
Hey, sometimes we miss, okay? When I was in 5th grade.
I would miss it all.
It's sad, but that's what happened. Could you imagine that happening these days?
Did it work?
So,
Did it really work though?
yes. So hi guys. I'm excited. Why did you stop?
All right. I guess.
Why did you stop? Okay, so I'm going to see you later, another term. Get your permit still up. Alright, so, let me explain why this happens. This is what I'm trying to mean. So like for example, if I said what is the sine of negative 30 degrees? Okay? Let's go back to our unit circle. Huh? You can explain that to you. That's a theorem. I don't know. Anyway, so the sine of negative 30. Where's the sine of negative 30? Right there, huh? And what is the sine of negative 30? Negative a half. What's the sine of 30? A half. See how they're on opposite sides of the y-axis? And since since y is the y-axis, they're on the opposite sides. Aren't they going to always be the opposite value? Where's negative 90? Down here. Where's 90? They're on the opposite sides of the y, so they're always just going to be the opposite value of what originally it would have been. Here's hence y, okay, y, that is just negative sine of the original angle. Okay, now y, does cosine absorb it? By the way, just a curiosity, if you have to before that's the one off. Okay, now why does cosine absorb the negative? Well, let's go back over. So, cosine of 30. Cosine of negative 30. Look, isn't their x values the same?
Yes.
Cosine of negative 90. Cosine of 90. Their x values are the same because we're looking at the x values. Hence why they absorb it. Once again, what is sine really quick? I mean tangent. Sine over cosine. So hence that's why it's also negative because what does sine do? It pulls out the negative, doesn't it?
Right.
Does that make sense?
Yes.
1 through